Good morning. I am Vaishnavi Patarkar, student of Pay Computer, and I am here to present project report on hard disk prediction. So here is the abstract. We all know that in the healthcare industries, huge amount of data is collected every day, and it contains hidden information which can useful for analysis and effective decision making to provide appropriate result on data. And this data is collected by some advanced data mining techniques. So in this project, we have studied the machine learning algorithm such as logistic regression, SVM, decision tree, k nearest neighbor on this data for making prediction on risk level of heart disease to make heart disease prediction system. For, for that, this system we use parameters like age, sex, blood pressure, cholesterol, and obesity for prediction. This system predicts the likelihood of patients getting heart disease. So this is our index. So in our index, there is introduction, method, conclusion screen, code, and output screen. Then introduction. Our project objectives are we will perform analysis on heart disease dataset and predict whether the dataset is present or not. So in medical industry, among all diseases, the heart attack disease is considered as most prevalent and have high cases to gather information about the disease, symptoms, and progression. Medical practitioners conduct the different surveys and the report about patients who have typical symptoms. We have UCI heart disease dataset. According to UCI, the dataset has 303 instance, row, and 76 attributes, that is columns. But in this study, we only include 14 features among 76 because we guess that too many features will cause too much noise. So understand that meaning of the features. We have the responsibility to explain some of the attributes of our dataset for UCI as follows. So age, here we consider UCI as follows. There is a age in years, sex, male or female, chest pain type, then risk blood pressure, serum cholesterol in mg per dl, fasting blood sugar, then target. So these are the technical specifications of our project. So we required hardware we required for this project is CPU processor, that is Intel, RAM 8 GB, hard disk 1 TB, and output device is laptop. And the software requirements are Python, Jupyter Notebook for implementation, and the libraries we are using is Matplotlib, NumPy, Pandas, and Scikit-learn. So, in this project, uh, we were used lots of algorithm or methods. The first one is logistic regression. So, logistic regression is a supervised learning algorithm which is used for the classification. The assumptions for performing logistic regression algorithm on the dataset is there should be linear regression independent, feature and log odds. This algorithm can compute the probability of the classification with two outcomes. In this algorithm, we use sigmoid function, which is sigma z is equals to 1 upon 1 plus e to the power minus z. This function successfully maps the binary value between 0 and 1, which helps this can predict the output. For example, a dataset with target value present in our dataset with target value present of heart disease and absence of heart disease. When we perform the logistic algorithm on this dataset, the algorithm achieves accuracy of 84%, which means the man has 84% probability of having heart disease. Then another algorithm were used is SVM, that is support vector machine. The support vector machine is supervised algorithm. This can be used for both classification and regression problem. This algorithm tries to divide the dataset with the help of hyperplane and makes the predictions. It has two types, linear and nonlinear support vector machine. In the above diagram, we can see the classification problem. The dots are used for points. The dots are data points which are separated with linear margin, and the two support vectors and the data points converted with the vectors are used for prediction. The score for the cases is 83.0%. This algorithm also have kernel tricks for non-linear problems. Then next one is KNN. So in K nearest neighbors, KNN can be used for both classification and regression problem, and it is a supervised learning algorithm. So this uses ensemble technique and works well with complex dataset. This algorithm is symmetric approach to solve the classification problem. So decision tree, SVM, naive Bayes, and network are the different techniques to solve the classification problem. Classification problem. So in this, that means KNN tries to predict the correct class of the test data by calculating the distance between the test points and the training points. That means it calculates the probability of the test data belong to the particular class. In the regression problem, it calculates mean value. In this case, the score of classifier is 87% with 8 neighbors. This algorithm uses some techniques for distance calculation, Manhattan distance, Euclidean distance, and Minkowski distance. The next one is decision tree. This is also a supervised algorithm and can be used for both classification and regression problem. This uses ensemble technique that works with the complex dataset. This algorithm is symmetric approach to solve the classification problem. Decision tree, naive Bayes, support vector machine, and network are different techniques to solve the classification problem. This algorithm works by dividing the dataset into a tree-like structure based on some rules and conditions and predict the output. The score of decision tree is 79% with maximum features. So this is our conclusion screen. As the diagram shows, shows that it is the representation of all the accuracy score of all algorithms output. And now we can choose the best algorithm for the prediction as the observed that could be KNN, because it gives maximum accuracy in KNN. So in this code section, the first we importing the libraries. So in libraries, we import NumPy as NP, Pandas as PD, Matplotlib for graphical representation, and sklearn for importing some uh, test train test split method. Then next read the dataset. Here we read all the dataset using read underscore CSV command, and then print the dataset. Then next one is print the target variable count. So here, with the help of bar plot, we print the uh, dataset uh, for target variable count. Then next one is trend test split. Here we splitting the dataset two into two format. The first one is trend, and another one first for training purpose, and another for testing purpose. So here we use 30% for testing purpose and the remaining for training. Then next one is logistic regression. So first we try to trace a logistic regression algorithm. So in this, we use logistic regression algorithm for our data set. Then next one is KNN. So next we will try to implement KNN. Then SVM, and last one is decision tree. So with the help of these four algorithms, we uh, predict the final output for our project, which is the output which is prediction of heart disease. Then the final score is final scores we calculate with the help of uh, combi combination of four algorithms, and we use or we calculate the which one algorithm is best for our project. So calculating the accuracy for each project, each algorithm, the maximum accuracy defined is KNN algorithm. So KNN is best for our project. Then this is the output screen. So as we shown in above, so this is the output screen, and here we implement our project. So this is our project. Thank you.